Okay, last one. It's this wedge and a block on it. This is a common little trick for sort of making what people think are clever problems. So why is there a circle? I don't know. Oh, the hell? Oh, I'm using the eraser. Oh, gosh, this pen has like a sensor at both ends. So, ooh, you want to erase now? No, I don't. Okay. So anyway, let's see. You got this block on the wedge, and the block has a mass of m1. Wow, m1. Let's try that. And then the wedge is like that, and the wedge has a mass of m2. The height is like that. Okay, la di da da. So m1 is actually, let me put these. I'll put them up the side. Anyway, what happens is the wedge can slide frictionally along some smooth surface. So at the end, after this thing slides down, the wedge then initially everything's at rest. So u1 equals 0, u2 equals 0, and then at the end the wedge has some velocity v2 in that direction, and the block has some velocity v1 in that direction, which is, and so, sorry, v1 is, let me try that again. V1 is that way, which is 4.00 meters per second. Okay, so let's see, and M1 is half a kilogram. Those are 0 kilograms, and M2 is 3.0 kilograms, or 3.00 kilograms. So, what is the velocity of the wedge after the block reaches the horizontal surface? Okay, so the sum of external forces on this system is nothing. Okay, there's gravity acting on both the block and the wedge, but those are balanced by normal forces, or by the normal force from the ground here. Outside the system, there are no horizontal forces acting on these guys, so the sum of external forces is 0, which means total momentum is constant. Okay, so this actually becomes very simple then when you look at it this way, right? So initial momentum is m1u1 plus m2u2, and that's going to equal final momentum, m1v1 plus m2v2. So this is 0 equals, and then m1v1 is, let's see, it's 0.5 kilograms times 4 meters per second plus 3 kilograms times v2. And what that'll get you then is that 3 kilograms, let's see, v2 equals negative 2 kilogram meters per second. So v2 should equal negative, if I've done this correctly. Let's see. v2 should equal negative 2/3 of a meter per second. So 0.667, I guess, if you want to do 3 sig figs, meters per second for v2. So then the second question is, what's the height of the wedge? Well, this is frictionless. The wedge is frictionless. The surface is frictionless. There's no friction. No non-conservative forces here. So that's pretty easy too. Since this just slides down, energy is conserved. So initial energy, let's see. Well, let me try going for, let's see. So, let's see. Initial energy of the system, you have the block is h above the floor. So I'm going to say it's u g equals m1 g h. Since the wedge doesn't go up or down, we're going to ignore its gravitational potential energy because we can set it 0 wherever we want, right? And kinetic energy initially is, of course, 0. Okay, and then finally, at the end, ug equals 0. Kinetic energy is 1/2 m1 v1 squared plus 1/2 m2 v2 squared. Okay, so I know this is all crammed in. So let's see. Conservation of E mech. means that M1GH equals 1/2 M1V1 squared plus 1/2 M2V2 squared. Oh, let's see. What do we want to do here? V2 is, let's see, V2 is negative. I'm just taking this guy and resolving it symbolically. 0 equals this is negative, hold on. Yeah, M1 over M2 times V1. Is this going to really get anything? Oh, hell, just solve it. Just solve it numerically at this point. I'm sorry. So let's go for H equals 1/2 M1V1 squared plus 1/2 M2V2 squared all over M1 times G. And that'll be good enough for us. You know what? I don't even care enough to solve this. Sorry. Here's your symbolic answer. You solve it if you want to find it numerically. Anyway, that should be right. Yeah. So that's the review sheet. Good luck on the test.